another episode of A2 Chemistry, and today what we're going to do is A2 chapter 29, Carboxylic Acid and Derivatives. So in this chapter, there's a few things that you guys need to know. First is about electron withdrawing group and electron donating group. What is the effect that it's going to have on the strength of the acid? That's the first thing that you need to know. And also to know the explanation is very important in A2. Always come on in exam, by the way. Second thing is what type of carboxylic acid can be oxidized. So please go through it. And after that, looking at the content, we also have the reaction of acyl chloride and how to get an acyl chloride. So that you need to know. And also the most important part is the mechanism of acyl chloride, which is addition elimination. So you guys need to know how to draw your addition elimination reaction, mechanism. Please go through that. And I would say other than that should be all the other reaction of acyl chloride. So please go and memorize everything. And that will be all. So please enjoy the content and jot down every notes. See ya. Bye. Are they strong acid or weak acid?
Strong.
Carboxylic acid is a weak acid, please. Wait. Well, I'm very stingy. I give you guys like just a tiny. I swear, it's every single time. Okay, so this one lucky more stingy. When they dissolve, how? Partially, right? Very stingy. Alright, guys, if I have a carboxylic acid, MK lah, you guys.
That's fucked up. Are you thinking against the homosexual community?
Okay, so guys, again, when carboxylic acid dissociate, it's always the H here, right? That will get donated away. Deng, 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 deng. That's it.
Did he still play Clash Royale?
No,
Yeah,
I never played Clash Royale.
How have you not?
Huh? Who played Clash Royale?
All of us.
Don't lah.
Yeah. Clash Royale.
Oh,
Clash Royale. Really? I thought you guys. What games you guys play? Minecraft. Are you guys in the Minecraft era?
Minecraft is crazy.
No, you guys are not a Minecraft, right?
How did I get the joke already? Didn't know.
Alright, guys, next. Alright, guys, for carboxylic acid, right, they are more acidic than alcohol, yeah.
You continue this for 20 seconds to win, right?
Alright, guys, now let me explain on why carboxylic acid is more acidic than alcohol.
Minor, your favorite.
Alright, guys, now let's look at the carboxylic acid. Alright, kid. Okay, look at this oxygen atom. Please tell me, what is the property of oxygen? Highly electronegative. Remember, yeah, oxygen atom is always highly electronegative, right? Which is a strict Asian parents, like a very strict Asian parents. Okay, so do you play Roblox with your friend? Sir, Roblox. I don't even know how you guys play Roblox. You know, I was curious once. I logged onto the Roblox website. Bro, it's like what kind of rundown website? It's like a very sad one. I don't know where all the kids like 2D shit. Why? Who play 2D game? Why you play 2D?
Hey, sometimes it's not.
Sometimes can't believe. I immediately I saw the 2D walking around like nope. Not yet. Alright, so guys, you see, right? This is a highly electronegative atom. Okay, so which means, right, they're gonna suck all the electrons away and towards them. Understand? So the electrons, right, will get drawn towards them. Can see that? Okay, so they will just draw all the electrons towards them. Okay, so since they are drawing the electrons towards them, right, we have a new thing, we call it as electron withdrawing group.
Can you just write EWG?
You can just write EWG. Okay, electron withdrawing group. That's it. Okay,
Pick the atom holder.
No?
okay.
This is the temperature.
So OH bond in the carboxylic acid, right, is weakened by the carbonyl group. Can see that, guys? You see the electrons being drawn towards the O? Can see that? Yes,
So they are more acidic because they're able to switch.
because OH bond is weakened by electron withdrawing group. So it's easier to break. Okay? Right, guys, what about your carboxylate ion? You see, right? When the carboxylate ion is formed quite stably. Okay, let's look at the carboxylate ion. Alright, guys, this is a carboxylate ion, right? Carboxylate ion. So carboxylate ion, the same thing happens. All the lone pair, right? The negative charge also being drawn, being sucked towards the O here. Can see that? Sir, can you go back, please? Where? Here. Go right down. Yeah, physically just take it. They just draw it towards themselves. So guys, the carboxylate ion is stabilized by the delocalization of electrons into a C double bond O. Highlight the word. Carboxylate ion is stabilized by the delocalization of electrons. So guys, the delocalization spread out the negative charge on the carboxylate ion, hence reducing the charge density. Okay, so guys, what it means by here, you see, right? Let's say if I put a H plus, this H plus, right, is less likely to go back, yeah? Why? Can anyone tell me why the H plus is less likely to go back? Because the negative charge is being drawn towards the O. Understand? Can see that? Which means the charge density is reduced right now. Hence, it's less likely to bond with a H plus. Alright, guys. Last week, right, we talked about phenol. Okay, so let's go back to your phenol again. You see, kid, phenol, right, I did mention about electron donating group. Remember, yeah, as long as you have electron donating group, it always strengthens the OH, makes the acid weaker. Now we have the opposite. Guys, let's say if it's electron withdrawing group, what's going to happen? Okay, it's going to weaken the OH bond, right? Am I right? Which means EWG will always make the acid stronger, remember, yeah? EWG will always strengthen the acid. Why? Because EWG weakens the OH bond. Understand? So the OH bond is easily broken right now. Okay, so EWG also extend the delocalization of a negative charge on the COO minus. Okay, so further increasing the stability of COO minus. Alright guys, now let's look at the diagram here. So we have to explain on right hand side first. For the forward reaction, what happened? This electron gets sucked towards your EWG, right? Which means this OH bond is weakened, correct? Am I right? Which means it's easier to be broken, right? Correct. Alright guys, next. What about your carboxyl ion? The lone pair, the negative charge, where they go? They also go towards your, being pulled towards your C double bond O, right? Correct. Which means, guys, what happened to the charge density here? It's lower, right? Which means H plus hardly go back to, okay, which means your H plus will hardly go back to the COO minus. Understand? Alright guys, next. Page 2. Alright guys, now what are some examples of electron withdrawing group, right? So again, in order for you to have an electron withdrawing group, it must be with a highly electronegative atom. So example, we either have a C double bond O, or we have a CCl, or we have a CF. All these highly electronegative atom, okay, are example of electron withdrawing group. Alright guys, next. Let's go. So guys, now let's look at ethanoic acid, chloroethanoic acid, dichloro, trichloro. Which one is the most acidic? Yeah. Think about it. So wait, it's the last one. Guys, you see, this you only have one electron withdrawing group. This one, second electron withdrawing group. You have 3 electron withdrawing group. You have 4 electron withdrawing group. Do you see you have 3 CCl? Correct. Which means you have more electron withdrawing group, right? So guys, always remember, the more electron withdrawing group a compound has, the more acidic it is. Okay? Which means this is gonna be the strongest acid. Yeah? Yes. We Alright guys. Next, let's look at trichloroethanoic acid. Have 3 electronegative atom, right? Okay, so which means all this CCl, right, is gonna weaken your OH even more, yeah. So weakening OH bonding even more. Hence, the resulting anion is also stabilized more, making it the most acidic. Alright guys, now let's look at this part. I want you guys to put down an EWG here. Alright guys, how can you identify what are our EWG? In order for you to have an EWG, you must have highly electronegative atom, right? Kid, please give me some example of highly electronegative atom. Oxygen, fluorine, chlorine, nitrogen, correct. Alright guys, next. You see, right, kid, you should remember for EDG, electron donating group. So guys, should remember in AS, right, I did mention electron donating LQ group, right, they have some effect. Correct, they have a positive inductive effect. Let's say if it's EWG, negative. So EWG, right, will always have negative inductive effect. Remember, yeah? Which means, guys, when you have EWG, right, do they strengthen OH or weaken OH? It weakens OH. Which means, guys, carboxylate ion form is more stabilized or less stabilized? It's more stabilized. Which means the negative charge on your carboxylate ion, how? Okay, has lower or has reduced density, right? Has lower charge density. Alright, guys, next. Last one. Do you get a stronger acid or weaker acid? Stronger acid. Well done. That's it. Okay, so always remember, yeah, when you have EWG, you always have a stronger acid. Clear? Alright, guys, now the next part, I want you guys to write down EDG. Guys, please give me some example of EDG. What are considered EDGs? Correct, it must be an LQ group, right? Example, CH3, C2H5, C3H7, on and on and on and on and on. Alright, guys, for EDG, what is the effect it has? Positive inductive effect, remember? Guys, what positive inductive effect will do? Strengthen OH or weaken OH? Yes, correct. It's going to strengthen the OH. Okay, so guys, which means the carboxylate ion form is more or less stabilized? Less stabilized, huh? A second. I'll explain to you why is it less stabilized. So someone asked me, sure, why is it less stabilized? All right. Guys, let's look at the board. Okay, last year, if I have this carboxylic acid, guys, looking at this carboxylic acid, right, please tell me, is it highly acidic or not acidic? Not acidic. Why? Too many LQ group. You see a long LQ group. Can see that? What is electron? Donating group. So they're going to push all the electrons towards O and H, which means this O and H is super strong. You get me? So it's no way you can break it. Let's say, if there is a case where this OH is broken. So what do you get? You get O minus here, right? Then the H plus, right?
When H plus is very steep.
Correct. The H plus immediately go back. So this carboxylic ion is not stable. Why? You see all the electrons, where all the electrons coming from? So basically this part has a lot of electron, you know. The negative charge is super duper high. Immediately H plus go back already, which means your carboxylic ion is never stable. Understand? Okay, clear? So guys, this one, your carboxylic ion is stable. Why? Because the negative charge, bye-bye, go here, right? So this H plus hardly go back. Understand? All right, guys, next, let's continue. So I can mention that your negative charge density on your carboxylic ion is increases, right? Also get because all the CH, they just push it.
Mine already.
So all the electrons, they just push it to the next. They just keep pushing to the next.
Actually, I lost.
And the group at the end gets stronger.
But I can.
Okay.
Okay.
So eventually, right, let's say if it's just an alkane, they will just push each other equally. Let's say if this is alkane, right, so they will just push each other equally. So eventually there's no net movement. But let's say if it's not an alkane, let's say at the end there's an OH, then everything is pushed towards the OH. Let's say if it's a ring, then everything is pushed towards the ring. It depends on what is connected at the end. All right, guys, now let's go. Okay, ethanoic acid is the weakest acid. Okay, so due to methyl, why? Again, we have methyl electron donating group, right? EDG, right? All right, guys, please tell me now. EDG, what's the effect? It's strengthened. OH bond, right? Which means it pushes electrons towards the COO group, making it more likely to accept a H plus ion. So, yes. Ethanoic acid. Why? All right, guys, page 3. Do the bottom question. The box don't need to do. I can't look in this link, huh? Why got ID and password one? Huh? Sorry? Help label. Why no? You like her, is it? You like her, is it? Send to intro to Johnny. Johnny like all the minors.
Sorry.
Scroll down.
Below 16 also he like.
Okay, I'll get you the structure. I want you guys to get me the answer. Yes. Let's end class. No.
Benzoic acid.
Okay. Phenol methanol is like that. Alright, guys, we have these three thingy. Please tell me which one is the most acidic. Phenol is the most acidic, Rob. Think about it, guys.
Benzoic acid. Because it's definitely not phenol methanol. I think that's the weakest. Okay,
it's definitely not phenol methanol. You're right. Phenol methanol is the weakest. Well done. Why?
Because
What is this?
very long.
Electron donating group, right? So I know that methyl phenol methanol is definitely the least acidic. Okay, next. What about this one? Benzoic acid is the most acidic. Well done.
That's this the CO play a big role?
Yeah, why? What's this? This is an electron withdrawing group, right? What EWG will do? Strengthen OH bonding, right? Okay, last one. Phenol is the middle. Phenol is a weak acid, but still weaker compared to a benzoic acid. Reason being benzoic acid has electron withdrawing group, right? Alright guys, now explanation. Yes. So I can say that a benzoic acid has what? Electron withdrawing group. Correct. Which means there is a negative inductive effect on. You see the bubble O, right? Which means your OH group is weaken or strengthen. Oh, weaken. Right. So OH bond is weakened, which means H plus is easily donated, right? Thank you. What about the second one? What about phenol methanol? You don't need to talk about phenol. Usually we always ignore the middle one. We should talk about the strongest and the weakest. Guys, phenol methanol has what? What? Partner. Has electron donating alkyl group, right? What effect? Positive inductive effect. Done. What happened to your OH bond? Well done. Guys, let me tell you, questions like that is 100% coming out in your exam. 100%. Now you either get acidic or basic. Okay, 100% coming out, yeah. Look at this. I already circle for you guys. Hey guys, phenol. Can anyone tell me why phenol is a weak acid? What's the reason we just did it?
Because you don't specify.
Yes, correct. Okay, guys, go into the ring. You don't tell me phenol has electron withdrawing group. No, they don't have an electron withdrawing group. It's delocalized into the pi ring. Well done. Okay, good job. Lone pair on oxygen delocalized into the pi ring system. Okay, weakening your OH bonding. Well done. Good job. That's it. Very sexy.
Design.
Sexy, but not sexy, right? You don't like it? Go touch very nice to touch. It's touching, is it? You can't stop.
Oh, bacteria.
Right, guys, next. Oxidation of carboxylic acid. So to decide whether is it stronger, yes, correct. Guys, again, to decide whether is it stronger or weaker, I already have something listed down for you guys here. Find your EDG, EWG, and that's it. Okay? It's always like that. Okay? It's always like that. Miss, can you restate phenol part? I think you rap. Okay, guys, what happened to phenol? Please tell me why phenol is why phenol is an acid again?
Why is it acid?
Why is it an acid again? Why is it a weak acid again? Because the lone pair on your oxygen overlap with the delocalized pi ring system, weakening your OH bonding, right? I'm not rapping. You sure one time? Here.
Actually, you got them slow. I thought I need to watch recording. I need 1.25 speed.
Yeah, same.
I also.
1.25 hours.
Bro, I talk fast, people say, sure, you go too fast, you rapping. I go slow. Okay, now recording, you guys do whatsoever you want. 1.25, 1.5 is okay. I cannot go fast. Is it people complain?
1.5 is too fast and you cannot understand.
I remember 1.5 is to understand it.
Well,
Yeah, I actually thought them slow.
why? You like it faster? Bro, so weird, you guys. Alright, guys, now oxidation of carboxylic acid. I'm so lost when you say pyruvate. No, I never say pyruvate.
That's why.
Yeah, I never say pyruvate, baby. I'm not a bio teacher, ha. Okay, so yeah, I said delocalized in the pi ring system. Pi ring system, not pyruvate. Alright, guys, let's go. Oxidation of carboxylic acid. Alright, so again, primary alcohol can be oxidized by acidified. Guys, potassium dichromate formula.
C7.
The AS reaction. K2. Cr2O7, please. So guys, oxidized primary alcohol, what it turns into? Something. What is the something? Yes, thank you. Okay, then further oxidize. Oh, yo, okay, what? Still remember your AS stuff, ma? Not bad. Alright, guys, highlight this. Metanoic acid and ethanoic acid can undergo further oxidation. Yeah, ethane dioxide is different thing. Yeah. So it's ethane dioxide acid, not ethanoic acid. My bad. It's ethane dioxide acid. Guys, you know what is an ethane dioxide acid? So ethane dioxide acid is 2 carbon, 2 carboxylic acid. That's an ethane dioxide acid. Understand? This came out in your exam. Okay, this quite popular in your A2, yeah, ethane dioxide acid. I want to see because I remember no, let me check the new syllabus. I think it's still the same thing. Is it still in? Just give me a second. Let me check first. I think it's still in now. I never remove 2025 to 2027. Wow, they keep changing the syllabus nowadays. Every time. Give me a second. What?
He's saying you got no eyebrows.
No, I say it's very short. No, it's very short.
Oh my gosh. But metanoic acid is oxidized by a Tollens reagent. Okay. Oh, so this is Cu. This is a Fehling solution. So guys, please tell me, Fehling solution plus what it turns into? Red PPT. Correct. Brick red PPT is formed, right? Nah, it's fine. Alright, guys, what's a PPT? Cu2O. Yeah, I get you the equation. C11O OH. When you react with a Cu2 plus and OH minus. And guys, when you oxidize metanoic acid, can anyone tell me what it turns into?
Oxidize.
Yeah, sorry. Oxidize a metanoic acid. When you oxidize a carboxylic acid, what it turns into? No. Sorry. No, oxidize. No, the product is the easiest after all. Alkene also come out. Die lah, you guys. No, wrong. You guys are angry. Yeah, oxidized carboxylic acid. No. You can. I show you. Oh yeah. I got the answer already. CO2H2. Oh yeah, CO2H2O. Only for metanoic acid.
Remember the day?
Yeah, CO2 and
That's the one.
That was different. That was like the 2R is still
I don't understand. I still don't remember
the
the
2H is still 2.
okay, so CO2H2O 4 2 plus 2 Cu CO2 3H2O. That's it.
So that day you're talking about something.
I remember
right?
you
The
always spoke us on
2H and
Yeah, because the R breaks, right?
That's alkene.
then after that 1R 1H is ketone.
Ketone. Then
Alkene cleavage.
alkene cleavage, correct.
No,
It's alkene cleavage is also oxidation. Alkene cleavage is also oxidation.
I don't remember your cleavage.
Yeah. Okay, that is also known as alkene cleavage. He's not wrong. Some
2H is CO2.
CO2H2O.
1R 1H is alkene.
Then carboxylic acid.
Yeah. And then
2R is ketone. Now you still need to know that, yeah. It's still in A2. You go refer to your AS stuff. Later.
Next is CO2 is two.
Alright, guys, next. If you use Toland's reagent,
Silver.
silver mirror, right?
Then
1R, 1H is aldehyde, then oxidase with oxidase.
He's right.
Then after 2R is ketone.
Correct.
I remember now.
Yeah, correct. Well, should remember, right? Good. So, guys, again, when you oxidize methanol acid, what it turns into?
CO2.
Thank you so much. CO2H2O. So why methanol acid is a strong reducing agent? You don't need to know that. You just need to know that only methanol acid can undergo oxidation. That's it.
So these reactions.
No need. I just put it down for fun. I don't even know why I'm writing it. Yeah, serious. I'm gonna really, I really need to remove this box already because this equation never come up.
Sure.
These two.
I actually can't take it.
Ignore. Really, you can ignore. Really. I just forgot to take it out. You can really ignore it. Suddenly come out. I still cover, so you cannot. Yeah, I always have a way.
This guy.
Yeah, this guy, bro. I should be a lawyer.
I'm gonna jump on it.
Whoa. Alright, guys. When you oxidize the carboxylic acid, go balance the equation. What it turns into? Okay, let me mark attendance first. Kason is here. Amber is here. Abby skip class. Elvina, Elvina also skip class. Kaylin also. Oh, yeah. Your girlfriend,
I'm sorry, what now?
The cute voice one.
Yeah.
Isn't that
Stu Ann, Levin, Junshen. Sharifa is here. Adriana, Sujai, Takito, Tandia online. Nurania is here. Tanya is here. Shritan, Sherling, Hussein, Lisa, Cassandra, Oliver, Katie Ying. Huh? Hey, Amy not here. Surprisingly, Danvin, Jonathan, Johnny, Landers, why got Landers? Oliver is here. Okay. Alright, guys, let's continue. Okay, what it turns into? CO2 plus H2O. Alright, guys, last say, right, if you use a stronger oxidizing agent. Okay, so oxidizing agent, okay, highlight the word ethane dioric acid or methanol acid, right? If you use a stronger oxidizing agent, will occur with a stronger oxidizing agent here, such as KMnO4. So, guys, KMnO4, what happens? When you use KMnO4, what's the color change? Purple to colors, correct. Dichromate, orange solution turns green, right? All right, guys, now, this time, I want you guys to draw your ethane dioric acid. All right, guys, oxidize this for me. Go. Last time I have an assistant, then she prepared everything. Now I just have to keep upgrading it. It's very easy. No, last time, wow, you have to see my Gen 1 notes. I should keep my Gen 1 notes. My Gen 1 notes is not like that. My Gen 1 note, right? Last time my student, the first class with me, right? They copy down everything. Bro, that's a Gen 1 note. I'm not kidding. I shit you not really. They copy down. I just write on it. That's a Gen 1, the first class. Happened in 201, 18 or 2 crazy. 201, 217. Yeah, I forgot already. Yeah, the Gen 1 notes. I still keep some of the Gen 1 notes. Later I try and find. I show you guys how lucky you guys are to copy anything.
So
Your senior very sad one, you know. I think I still have my Gen 1 already. Alright, guys, go. Let me find my Gen 1. I'm actually quite curious. Yeah, I still keep my.
10 years be 20 years old now already.
No lah, I started teaching when I was that early, ma. Told you already. When I was like 18.
32.
No lah, don't lie lah. Yeah, Gen 1 notes.
Oh hell no.
You like your Gen 1 notes? You see how lucky you guys are? Last time really like that one, eh? Yeah, serious. Gen 1 the first class first class, like the first class. Then after that, I just send this to someone, they just type it out. Then I just keep making it nice. So right now, you see, you guys are so lucky. You guys don't need to write all this. You see, last time, you see, the kids very sad one, Gen 1 notes, damn nasty, right?
Technology
Technology,
Anything like that.
Code lah.
Yes.
Oh.
iPad bro.
Yeah, I see Gen 1 note very cute, you see, your Gen 1 notes. You want this? If I send you this, I think you guys will just keep me as like lazy teacher. This teacher never prepare one. You see now you guys are so lucky, got colors some more. Okay guys, CO2 plus H2O, yeah. 2 CO2, right? How many H2O? 1 H2O only. How many O to be added?
Oh,
1, 2, 3, 4. 1, 2, 3, 4, 5, 1. Done. That's it. Alright guys, now, okay, let's look at this table. I want you guys to tell me, right, okay, if I take a methanol acid with a tolerance reagent, is there any reaction? Methanol acid, yes, there will be a reaction. Put it here. So what is observed? Silver mirror, right? With a phthalate solution? Yes, correct. KMnO4? Is there any reaction? Colorless, right? Good job. Remember what it forms? It's a CO2 and H2O, yeah? Understand? Alright guys, next. Ethane dioic acid with tolerance reagent. Yes or no? No. No reaction. Ethane dioic can never undergo oxidation with... Oxidation can only be with a methanol acid with a tolerance of phthalates. Ethane dioic is only happening with a stronger oxidizing agent such as KMnO4. So, no reaction. Phthalate? Cannot. Acidified? Yes, can. Colorless. Understand? Know the difference? This one you guys need to know how, under which circumstances, what type of carboxylic acid can be oxidized. Butanoic acid? Can? No. Phthalate? KMnO4? No. Too many CH3. Butane dioic acid? No. Phthalate? KMnO4? No. So conclusion, only metanoic acid and ethane dioic acid can be oxidized. Only these two. But these two can be oxidized under different conditions as well.
Let's go.
Let's go. No lah, what let's go?
Let's be.
Please really meh? Okay lah.
Yes.
You guys are.
Are you serious? One more page lah.
One more page, okay, one more page, let's go. Okay, so making acyl chloride. So guys, acyl chloride. Okay, so how do you make acyl chloride? Okay, so it's basically your AS reaction alcohol. Okay, so the reaction, right, is AS reaction. It's basically from alcohol to a halogenal alkane. Alright guys, do you remember how do you convert alcohol to halogenal alkane?
Yes.
Yeah, please tell me. PCl3 with heat. What else? PCl5. What else? Last one. SOCl2. Well done. Good job. You guys should remember that. Lovely. It's the same thing. It's the same thing. So basically, right, guys, you see, your carboxylic acid is like that, right? You have OH, right? So I can either add a PCl5, PCl3 with a heat, or SOCl2, then what it turns into? So you see, right, it's just alcohol. This alcohol turns into a Cl, that's it. Understand? So the reaction is just like AS, yeah? Okay, PCl3 with heat, PCl5, SOCl2. That's it. So OH has been replaced with a Cl. Alright guys, first one with PCl5. Write down the equation for me. I love you.
Oh.
Shut the hell up, bro.
30 minimum.
Because it's true.
40, so don't even know how to use iPad, lah,
So
bro.
maximum I said 31 lah, maximum.
I love you. lah.
Oh, so it's 35 lah.
But you just said maximum 31.
But you said like, there is like you.
Yeah, it means you're on point lah. Means
No,
you're right lah.
It means,
So you are 31 ah?
no. No, it means you're dating.
Maximum you can date 5 guys. Doesn't mean you will date 5 guys, right? Or you will?
No. Too many problems. One also cannot.
Ayo, you guys are. Alright, guys. Again, still remember your AS reaction. I'm gonna go back to your AS reaction.
He's 9.5.
Okay, let's look at your AS reaction for chapter 16, hydroxyl derivative.
Right.
Alright, guys, see the first one, right? Reaction with PCl5. Done. What it turns into Cl, POCl3, HCl, right? Correct. Go.
Day.
I'll try my best. Maybe stop making me laugh.
You want to go shisha later?
No, no shisha. I don't want. Fuck you.
Okay,
Huh? No, I cannot laugh like that.
Alright, guys, second one. I want you guys add PCl3. This time you need to hit it already. Alright, guys, try to write down the equation. I will show you where is it. Nah, AS note. Aye.
Maybe go back. Why?
People.
Yo, why you like that?
Me, why you like that?
Why you like that?
Why you 30 years old?
One of the reasons I never post anything, right? My friend keeps sharing, I cannot repost because once I repost, right, then all my students gonna know my age. That's why I have to.
Why? You should be. Oh,
You should be loud and proud. And you still look good at 30.
Maybe I'm younger. Right?
You already reached ang status.
Bro, this remind me of last week. I went to the gym, right? Then one of the instructor was bringing a baby, like a literally baby, like 2 years old. Then I walked to him, is because the baby is damn cute. Then,
you call him uncle, is it?
then you know what? My instructor, come say hi to uncle. I'm like, say hi to uncle, uncle. Oh, bro. Alright, guys, what's your answer? You have a Cl here, right? And what is formed? H3, PO3. Alright, guys, balance the equation. The equation is not balanced. How many H is needed? So you see, right? All the H comes from here, you know. Okay, so basically you need H3, which means you need 3 carboxylic acid, 3 ethanol chloride, propanol chloride. That's it. Alright, guys, last one. No, why? What time you? What age your parents give birth to you guys?
My dad was 13 and my mom was 30.
28 or 38?
My mom was 30.
Oh, 28, 30.
I thought your mom was
Yeah, I heard that also. Yeah. Alright, guys, go. The last one.
Then you give birth to them.
Right. True also.
So later when your son or daughter grow up, right? Then
What about you guys?
no,
The
no,
earlier the
they
better,
reach
mah.
their teenage years, right? Then their friends will think you're good.
You guys are so weird, bro.
It's just combination. Don't say me.
You almost incompetence sometimes.
You gotta think ahead, bro. I'm just transcended. Don't play.
Then you should lah, you should mah.
What?
But let's say if you give a son, if we give birth to a son now,
Uh,
when your son is 18, you're only like what?
I'm just saying, I'm almost ready. Insane.
Alright, guys, let's go. Last one. Turn into a propanol chloride also. Cl is here, yeah. Okay, and SO2 and HCl. That's it. This is also under room temp, yeah. Well done. Who you? How you know one?
Yes.
Well, not bad. Okay, guys, you see, right? If you use SOCl2, that's a benefit. One of the benefit, right, is it is easy to separate. Well done. Okay, on one reason, right, because everything, this is aqueous, this is gas. Okay, a product form is aqueous, and two gases escape. So basically, right, the product itself, it's the product itself, because all the byproduct, right, SO2 and HCl, they just vaporize, just escape off, right? That's it. Very good. Now we will stop the lesson here because some of you guys are rushing off for your further maths class. Okay, and I'll see you guys next week. Ken.
So,
Yes.
you said that methanoic acid is like the strongest, the weak. Oh, wait, no.
Sorry, come again.
Wait, no, I'm thinking. I forgot 1 second.
Ken, Celeste, I send it to you later.
Sir,
Yes.
would you go?
Welcome.
Could you go to page 1? I have a question.
Page 1. Yes, come.
Okay, so if we in the bottom of page 1, bottom. Okay, you're already there, right? Okay. Oh, and the last box. See all the molecules going to the oxygen. So that increases the stability of the COO minus group.
Oh, that decreases the stability.
Oh, okay. That makes it a weak acid.
Yes, all right. That makes it a weak acid.
So that means when you have more more hydrocarbon chain, the acid is weaker
Yes, when you have more hydrocarbon chain, the acid is weaker.
because all the electrons are going to the oxygen group.
All right. Yes.
Good. Thank you. Thank you.
Welcome. Welcome. Bye. See ya. Welcome. Whoa, finally back.
Please like and subscribe.
Someone can take it. Please like and subscribe.